Welcome to Anduski Lectures. Topic is phase diagram, Gibbs rule. Teacher Anand Mohandas. Phase. Each substance has three phases it can change into: solid, liquid, or gas. A phase is a part of an alloy with uniform physical and chemical properties and the same composition. It is separated from other phases by a definite boundary on the phase diagram. Now phases can change. Every substance is either solid, liquid, or gas at certain temperatures. The temperature and pressure can change phases. There are 6 phases a substance can change between these 3 phases: melting, freezing, evaporating, condensing, sublimation, and deposition. Melting is the transition from solid to the liquid phase. Freezing is the transition from the liquid phase to the solid phase. Evaporating is the transition from the liquid phase to the gas phase. Condensing, the transition from the gas phase to the liquid phase. Sublimation, the transition from the solid phase to the gas phase. And deposition, the transition from the gas phase to the solid phase. Temperature can change the phase of a substance. One common example is putting water in a freezer to change it to ice. Phase equilibrium. Phase equilibrium is reached when at a given temperature and pressure there is no further tendency for change in characteristics of the phases with time. A stable equilibrium state is like truly changing, and metastable state may be changing, but too slowly to be observed. Phase diagram. Phase transition can be represented with a phase diagram. A phase diagram is a visual representation of how a substance changes phases. Now here we have shown the phase diagram of water in liquid, solid, and gas form. Now you can see at 100 degrees Celsius, normal boiling point, 373.99 degrees Celsius, it is critical point, 0.01 degrees Celsius, it is triple point, and there is normal freezing point at pressure 1 atmosphere and around 0 degree Celsius. So this is the phase diagram of water. Now there is something called Gibbs phase rule. The Gibbs phase rule describes the state of a material. So the equation is the number of degrees of freedom is equal to number of components minus number of phases present plus 2. That is the Gibbs phase rule. Now, phase diagram of water is shown. There are 3 points. Let us find the degree of freedom at point C, point A, and point B. So the equation is degree of freedom is equal to number of components minus number of phases plus 2. So let us find the degree of freedom at point A, point B, and point C. And in the diagram you can see the point A, it's one phase, that is water, and one component, that is water. Now let us calculate the degree of freedom at point A, point B, and point C. So at point A in the phase diagram is all liquid and the number of components C is 1 and the number of phases P is 1. So the phase rule gives F equal to C minus P plus 2, which is equal to 1 minus 1 plus 2, which is equal to 2. So there are 2 degrees of freedom. Similarly for point B, the degrees of freedom is 1, and for point C, degree of freedom is C minus P plus 2 equal to 1 minus 3 plus 2 equal to 0. There are 0 degree of freedom at point C. All 3 phases coexist only if both the temperature and pressure are fixed. So you can see that point C, again, it is a triple point, So three faces coexist at triple point. Now you can see let us look into the point B. Degree of freedom equal to C minus P plus 2 equal to 1 minus 2 plus 2 equal to 1. Thank you for watching the video. Thank you.